In this video, we're going to be looking at cyclic quadrilaterals. What is a cyclic quadrilateral? A cyclic quadrilateral is a quadrilateral in which all the four vertices lie on the circumference of a circle. So we have the first vertex, this is the second vertex, this is the third one, this is the fourth one. So we can refer to this as a cyclic quadrilateral. Now talking about the theorem that pertains to cyclic quadrilaterals. The theorem goes that the opposite angles of a cyclic quadrilateral are supplementary. So which means that let's mark this angle as C, let's mark this as A. The theorem is saying that A plus C is equal to 180 degrees. That is what supplementary means. And so when we try to establish that theorem, we can try to join B and O together, and then we do the same for O and D. Now, by the fact that the angle subtended at the center is twice the one at the circumference, then the angle here is 2C. And the same thing goes for the angle that is here. This is the angle at the circumference. This is going to be 2A. So when we had 2A and 2C together, both of them are angles at the point. So this is equal to 360 degrees. And 2 is common, so we pick A plus C right inside the parentheses equals to 360. And so A plus C equals to 360 divided by 2. So A plus C is equal to 180 degrees, which further establishes this. Now we have a corollary to that theorem, that if one side of this cyclic quadrilateral is produced, let's say we're trying to produce BA, such that you have an exterior angle, right? So let's call this X. This exterior angle is equal to the opposite interior angle. Let's say this one here. So let's call this Y. So the corollary is saying that X is equal to Y. Now the explanation to that is this. Let's call this place W. Remember that the relationship between W and Y is that W plus Y is equal to 180. Why? Because they are opposite side of a cyclic quadrilateral, so they're going to be supplementary, right? So if we try to make W the subject of the formula, then we have W equals to 180 degrees minus Y. So which means that this can be changed to 180 minus Y. Now remember that 180 minus Y and X, which is W and X, are on the straight line, right? And the sum of angle on the straight line is equal to 180 degrees. So which means that 180 degrees minus Y plus X is equal to 180 degrees, right? Because these are two angles. And so when you do it through and through, you have minus Y plus X equals 0, and then X equals to Y, which is what we are trying to say, is that the exterior angle formed by BA being produced is equal to the opposite interior angle. So those are the basic theorems, right, on the cyclic quadrilateral. So let's look at some examples. Yeah, in the first example, we have to find C and Z. C and Z. 80 degrees and Z are opposite angles, so we can say that Z plus 80 degrees is equal to 180. And then we can also say that C plus 100 degrees is equal to 180 degrees. The reason for both is because they are the opposite angles of a cyclic quadrilateral. Now that being said, then we can say that Z is equal to 100 and C is equal to 80. degrees. So this is 100, and that's equal to 80. By the time you sum up the 4 angles you have, your result should be 360 degrees. In the second example, we have x and then we have y, but we have to find the marked angles, right? So to find the marked angle, you can start any way, okay, depending on your perception. I can start by saying that angle CBA, which is x, is equal to x, and then angle CD, beg your pardon, A is equal to 2A. So CDA and CBA. So x and 2x are, supplementary angles. So x plus 2x is equal to 180 degrees, supplementary angles. So this is 3x is equal to 180, and then x equals to 180 divided by 3. So x equals 16. So technically, we can say that this is 60 degrees, and this is 2x, which is 2 multiplied by 60 degrees. That is 120 degrees. And so we mark this as 120 degrees. Remember that y happens to be an interior angle to this opposite exterior angle, right? So we can say that y is equal to 100 degrees. The reason is because it is the opposite interior angle to the exterior angle DAE. Okay, I have written this, I shouldn't write this. Right. In this case, we are expected to find the value of x and a fundamentally, right? And then we can proceed to find 3x. So what we do here is we call this A, B, C, and D. And then we know that A, B, C, D is cyclic. So which means that angle A, DC and angle A, BC are opposite angles. They're opposite angles of a cyclic quadrilateral. Right. So which means that x plus 3x is equal to 180. So 4x equals to 180, and then x equals 180 divided by 4. And that's equal to 45. So which means that this is equal to 45 degrees, and this is 45 degrees multiplied by 3. We have 135. Now to find A, remember that there is a relationship between the angle at A, which is angle AOC, and angle ABC. And the relationship is the angle at AOC is twice the angle at ABC. So which means that angle AOC is equal to 2 times 135 degrees. That is equal to 270 degrees. So which means your angle AOC, or small a, is equal to 270. And the reason is because angle at center is equal to 2 times the one at the circumference. Thank you.